Hello, everyone. Nadeem here with PC.Solutions.Net. I'm with Mac. And Mac, how's it going on this nice Friday? Yes, it is. It is. Yeah. Yeah. Well, yeah. And there's been a lot going on. I mean, I was talking to one of my one of the business groups that I have, kind of a IT services providers group, and there's a lot going on about the future of what's happening. And one of the things that came up was how much debt these banks are taking on because of all these loans and stuff. So, and I never thought about it until somebody brought it up, and it was like, yeah, oh, where are all these PPP loans coming from? Well, the banks are floating them. So, are there going to be defaults? I'm sure there are. I mean, I don't know how all this is going to play out, but the bottom line was that all businesses, and this is specifically to IT-based businesses, MSPs, but I think it applies to all business. So, the moral of the story was at the end, it was like everybody's got to look to the future. So right now, yeah, things are not as good as they could be, but we need to kind of focus more on the future as opposed to what's happening right now. Uh, so that so with that in mind, we're gonna where everybody's tightening their belts and getting ready, hunker down, and get ready for it. So we're ready. I mean, we've been. I was thinking, when this started that you know the the bad part of the economy hasn't hit people yet. That's going to hit. I mean, people are still float. I mean, they still have money in the bank and savings accounts, whatever have you. It's going to hit us when a lot of these companies and people run out of that money that's in the bank. What are you going to do then? Uh, that's when it's really going to hit the fan. So I don't know what people are going to do, but one day at a time. So for right now, right now, we have a lot going on in the technology world. I mean, there's a lot of R&D. And by the way, you mentioned running around. So I killed my Surface laptop. Um, and not to promote any specific company, and I don't want to promote any specific company because the company I'm going to talk about, they don't play well with partners. Uh, but they make a good product, and that's why I like their products. But anyway, so PCs, laptops. I have never had a PC based laptop that has lasted me for more than a year and a half. Something happens. Well, number one, the keys rub off the keyboard anyway. I mean, they just rub off. I mean, it's just like there is no ink that can stand my fingers, I guess. But but besides that, and I don't need to look at the keys, so if they rub off, I'm fine with it. It's muscle memory for me now, so I've been doing this for so long. But something else failed. Either the keyboard will stop working, or the display will have issues, or something. So my less than a year old Microsoft Surface Laptop 3, it died today. And fortunately, I was downloading a video that I needed to edit, and I was downloading it. In the process, I heard this weird beep I've never heard before, and I was like, "Well, what's that?" And then all of a sudden, my display just went black. And yeah, and what happened was the backlight died, and I can kind of see the ghosts on behind the screen. I can see some stuff happening, so I knew my backlight was dead. So, of course, it was still under warranty. Called Microsoft. They said, yeah, they'll replace it and, send the machine in. Once they get it, between 7 to 10 days, they'll ship me another one, blah, blah, blah. You know, the only machine that's lasted me for more than 2 years was a MacBook Pro. It lasted me for about, I think, 5 or 6 years. And the only reason I got rid of it was because it got so old that I couldn't install the latest version of Mac OS on there. So I got rid of it. Um, but I mean, that was the machine that just worked. I mean, I could rely on it. hopefully this is a one-time fluke and the next machine they send me will work. I mean, I work the machines hard. I know the laptop 3 is probably not meant for, graphic editing and things like that. And my new, this new resolution that I have, a video a day, maybe it's pushing the limits on that machine, because I know when I'm editing or transcoding video, the fans are kicking in, and you know, and it doesn't have a dedicated GPU in it like the MacBook Pro does, which but I mean, I killed it, and hopefully the new one will be better. But anyway, so Mac, I know we discussed, a little bit. We touched on a few topics what we were going to talk about. So what are we going to talk about today? Yeah, so one of the things that well, for me, when people say AI, what comes to mind is big pharma, right? Pharmaceutical companies are big on AI. The other thing comes into play is uh, you know, genes, genetic stuff, like gene sequencing and stuff like that. So that comes to mind. However, one thing, AI is at a spot where the cloud was like a year ago. Not a lot of companies knew that they were using the cloud, but they really were. And I remember, one of my seminars that I used to do, and one of the questions I had in there was, whoever uses the cloud, raise your hands. And less than 50% of the room used to raise their hands. It's more now, but then I would start to ask those people who did not raise their hands, how are they not using the cloud? What are they using for email? Where is their website hosted? What applications are they using? And once we asked those questions, we found out that, more than 50% of the 50% that didn't raise their hands, they were actually using the cloud. They just didn't know it. So when it comes to small business, we're in a similar situation. We may not think that we are using AI, but pretty much everybody using any recent version of an application out there is using AI in some way, shape, or form. And what I mean by this is, if you're using PowerPoint presentations and you're using the auto formatting deal in PowerPoint, you're using AI. If you're using Excel and you're using some auto formatting in Excel, you're using AI. If you're using Outlook Web Access and you're letting it offer you grammatical corrections or word corrections, you're using AI. So AI is built into these applications, and that as time goes on, it's going to be built in more. It's going to be ingrained more in these applications. So there is no getting around that. AI is here to stay. It's going to be it's going to be here for the near future. Now, the question becomes, what changed? Where was that tipping point? What happened? I know humans have tried AI for in the past for so long, and it just failed. It used to fall flat on its face. What changed is we learned that the way to train an AI model is not by letting a human train it, but let it train itself. So the tipping point came in when we figured out that the way to train an AI is for the AI to learn for itself from the raw data. So once we figured that out, now it's just exponentially increasing in its intelligent factor, right? The intelligence factor. So what I mean by that is, take the example of, for example, let's say, Tesla. How is Tesla training their cars to self-drive? Well, they're using AI. They're using it. So there's no human sitting there programming, if this happens, then do this. That's not intelligence. That's a simple, if this, then that. That's not intelligence. So now we figured out that if we can feed the raw data to a system, and then the system can decide and factor out intelligence based on the raw data, that's the intelligence that we're looking for. And and this system works for in a lot of different organizations, so a lot of different circumstances, a lot of different industries. So for example, we can teach a car how to self-drive. We can, from simple things like, for example, we can match up human faces to certain known faces, so we can do identity management. Kind of like when you look at your new Microsoft Surface machine that just died for me, and it automatically logs you in. It knows who you are. It's using AI on the back end, right? uh, we can figure out, like, if we're trying to track down criminals, we can track them down just by using facial recognition. um, I'm not going to get into some specifics, but you've probably read in the news, FBI cracked down on this big Nigerian group, and I think this group has some of my machines. But anyway, so um, so the the thing is, the agencies that were involved, they can factor in so this group was big on social media, right? I mean, they were tooting their own horns, and they were just flaunting money and all of that. It's one of those easy come easy go type of situations. But well, based on their social media profiles, the systems were able to pick up things like, where could they be located because of the way the shadows are, the time, what's in the background, things like that. So the system is able to identify where they are, what they're doing at what times, and it builds like a profile. So with AI, we can process a lot of information using this. Now, combine that with the cloud. What we did is we have a lot of compute power now, in these cloud-based systems. So we are able to use this cloud compute power to build our AI models, to have that machine learn faster than a human can learn. What I mean by that is, a human learns over the period of a lifetime. So from childbirth, we're learning, yeah, we're learning a lot when we are toddlers, right? Well, an AI model can learn a lot faster than a human can, not just then when they're toddlers, when they're learning at the highest level, but any time during a human lifetime. An AI model with the processing power that's there can just learn a lot faster. Now, an AI model does not have all the sensors that a human has. So that's a big limitation, but we're getting there. I mean, we are building more and more sensors. We are deploying more and more IoT sensors out there into the world, so that these AI models are learning faster, and they're learning new inputs, right? So for example, touch, it may not be as good as we want it to be, but we are working on that. We have sensors that are learning that. Smell, that's another sensor that we need to kind of improve on. So once these IoT sensors come into play, then the machines can collect a lot more data, and they can make more deductions based on that. Now, for a small business, whether you like it or not, you are using AI in some way, shape, or form. If you are using web access, you're using AI. If you're using, PowerPoint, Excel, any of the Office applications, you're using AI. So it's here to stay. There's no question about that. What can AI do more? So um, uh, think of it like you're on your social media page, and all of a sudden, this social media page is offering you ads that for something that you were thinking of recently. So the way it's doing it, that is picking up on metadata and on cues that you've left. So maybe you searched Google for something, or you search something, and that data is consolidated by the search engine, and then that is disseminated out to these social media engines that are now offering you ads on what you were maybe searching for or doing some research on. So it's not magic. I mean, a lot of times it seems magical to us, or at least it seems magical to me. How does so and so social media service know that I'm interested in this product or service? Well, it's picking up on these cues. Now, if we look at the raw data that they have, then it all of a sudden it makes sense to us. Oh, yeah, well, that's easy. Well, it's easy once we know how it's done. Just like anything, it's easy once we know how it's done. But small businesses, the really successful ones, are the ones who are going to take on this AI and start implementing this just like the large pharma is doing, just like the large enterprises are doing. When you start to roll that AI out into your specific industries, that's when the big change is going to come. I'll give you an example. Let's say you're manufacturing widgets. And I'm going to give you a specific example of one of our customers, the specific industry. So let's say you manufacture these automated windows, okay? And a lot of people probably know who I'm talking about. But so now there can be a window that has an open and shut cycle of so many hours, so many open and shut cycles. Let's say it's 10,000. Well, that's your mean time before failure is 10,000 open and shut cycles. Well, that's an average on millions of data points, right? And you've averaged it out and you figured it out, and that's what it is. What you don't have is a sensor that has detected certain things to determine if you are reaching that point of failure, because there are certain things that you can sense that will lead you to believe that the window, that a failure is imminent. Kind of like what we used to have, that smart feature in hard drives. I don't know if people recall, but there used to be a SMART feature in hard drives. And what it was, a predictive failure where the drive did its own diagnostics and it could predict its own failure based on certain things. And these certain things are, for example, in the case of Windows, it could be the sensor on the bearing detecting higher than acceptable temperatures. It's a simple thing. Once you think about it that way, once you break it down, it's something simple. If a bearing is being worked, let me give you another example. Let's put an IoT sensor in the bearing of the wheel of your car. Now, if that temperature goes beyond a certain threshold, then we know failure is imminent. And that's how a lot of people who are driving big trailers, what they do is they'll actually get out and they'll touch their hubs or their bearing, trying to get a feel for how hot is it? Do I need to pull into the next stop and swap out my bearing? Well, if you have sensors in there and this data is being collected, now the AI, what it's going to do is, you don't have to tell it what that failure temperature is. It will learn from historic data. So if you have that sensor that's feeding that data into the system, well, over time the system learns from it, from that data, and it knows, okay, well, this is normal. It's been happening for years. Now all of a sudden one day that temperature spikes, and it's good. Whoa, hold on, this is not normal. Something's happening here. And that's when it can throw a flag out there and say, hey, dispatch your truck, whatever your truck, do a truck roll, and let's get that bearing replaced in window so and so at building so and so, whatever have you. So these kind of things can really streamline the service industry. I mean, it can streamline, for example, this company that makes widgets. In this case, it could be, windows or wheels or axles or whatever. So you can actually proactively do things in the field before bad things happen. So you can actually replace a component before it really fails, because magic, right? So that's all the end user needs to know is magic. It's like, one day a tech schedule is like, hey, I need to replace, so and so on your window or your car. And it's like, well, wait a minute, why? I don't know. I don't have any problems. Yeah, but you're going to. So that's the magic of it. So that's why AI is here to stay, is because we can better understand the data, because we have better sensors now, because we can handle all that data coming in from sensors. And that's all these self-driving cars are doing. is collecting all this data and then basically deciding, based on historic data and analyzing that. And just because there's a lot more compute power available now, not just in the cloud, but also locally. So, what Tesla is doing is something interesting. So they're actually processing this within that vehicle. So the vehicle has enough processing power where they are doing this internally without having to send all this data to the cloud. They're still sending the data to the cloud for model building. They're still building that model, but they can process this in real time locally. So even if the car does not have a good connection, it can still make the decision whether it needs to stop at that stop sign or speed up. We can't wait on the cloud to make that decision. So so the and what's kind of enabling us to do this now is we figured out the how GPUs, graphic processing units work, right? So and I think that's what killed my laptop, by the way. But anyway, so yeah, so the GPUs can process a lot of threads, which means they can process a lot of different types of information much faster, staying using less power compared to a regular CPU. So a regular CPU is a CISC chip, right? So it's a complex instruction set chip. I think I touched on one of my videos not too long ago about this. A GPU or a RISC chip, a reduced instruction set chip, it only works with a few instructions, but it can process a lot of them quickly, and so it uses less power. It's faster. It doesn't use as much resources, but it can make that decision for you. So using GPUs for these AI-based processes, because an AI process is not going to do, it's not going to try to do everything under the sun. It has a specific model that it needs to work on. And for in our case, that model is, I just need to know the historic data points for the temperature on these bearings and just throw an alert when it gets outside of those thresholds. It's simple. And a RISC chip is excellent for doing this kind of stuff. Now, in your cloud models, you can actually get machines that are RISC based compute models, that are RISC based chips. And I know in Azure you can get, GPU, virtualized GPU machines, VMs, that can process a lot of data. So for small companies, small to medium sized businesses, where you may deal with bearings, you may deal with compressors, you may deal with certain hinges. These kind of things can you can collect that data using IoT sensors, then build your model based on that data, and then predict the future, what's going to happen, how long your widget is going to last in the real world. I only wish that Microsoft had done something like that with backlights. They didn't, and that's why my laptop failed. But eventually it will get there. Eventually we will get to a point where my laptop might tell me, "Hey, I'm predicting failure. Go ahead and get this warranty replacement done now because I know I'm going to fail in the next so many hours." And then if it can just send that data to Microsoft or the manufacturer and say, "Hey, send me that advanced replacement machine ahead of time because I'm going to fail," it'll be like magic to me. My new machine will arrive before my old machine fails, and I'll be ecstatic, and it'll be nearly no downtime for me, and I'll be like, "Hey, Microsoft, you did a good job." Right now, we're not there yet, but we are going to get there. The technology exists. The data modeling and the capability exists. Somebody needs to simply implement it. um, so I think we are going to get there. Like we are embedding this AI into our regular office applications that we use, like we're embedding them into, for example, the login process that we do with our machines. It's only a matter of time it's going to happen. Okay. So, how AI is going to be used now? One thing I was thinking while you were talking, Mac, I don't know if I'm capturing your audio. I may not be. So we'll have to figure out. I'm just going to repeat. So, how are businesses like, for example, legal and some of the other, small businesses doing using AI, and how can they use AI to help with business? So, uh, in similar, we can use AI with using similar models. So the example of the temperature that I gave you, so it could be based on, so for example, an AI deciding for a law firm whether they should take a certain case based on certain criteria, yes or no, right? So now you don't have to have, you don't have to wait on that one, partner that decides whether they're going to take the case or not. You can train your AI model to do that for you. The other thing that's happening is in the medical field, for example, uh, diagnosing certain diseases. And this is actually, there was a proof of concept done, and there was some prototyping done, and the probability of AI determining and diagnosing a disease is better than a human doing that. So think about that. We haven't even implemented it yet. We did some trials and we found out that AI can do it better than a human can, because AI is not going to be emotional. AI is not going to be, moved by some factors that a human is going to be moved. So, so AI can do a better job there. Now, of course, there are certain things that AI cannot do very well, uh, only because AI does not have enough data, so it cannot do very well. So, for example, think about trading stocks. AI cannot do that. AI cannot do that very well because stocks can jump up or down, the values can jump up or down based on a rumor. So unless you can figure out how to feed rumors into the AI, the AI doesn't have all the data that determines the value of a stock. So AI is not going to make a good stock trader, right? Because it just does not have all that input. So I mean, when I say input, stocks vary in value based on so many different inputs from the real world. It could be weather, it could be just rumors, it could be religious activities, it could be just temperatures in certain regions, it could be a friggin' dust storm on the other side of the world. So it could be so many different things that, and we haven't figured out how to input all these things into the AI model for it to be able to better extrapolate the output, so better predict the future. Um, I'm talking about this, and my thought, I just, something just clicked with me. There was a movie, actually, there was a series. I forget the name of the series, but it's a recent show that's been going on. Anyway, I watched a little bit of it, but this guy who built this computer model and fed everything about every person in the world to this computer model so it can predict the future, and then this computer model started to kind of uh, predictively say how to do certain things. And so basically, what it means is this guy who owned this computer could control the world. So it was, and I'll remember the name of this show. But anyway, so it was very interesting. You know, there are certain things that we don't have yet. So one was the the level of compute power that will be needed. We don't have that yet. Yeah, we have a lot of compute power in the cloud, but there is a cost associated with that compute power. It's not free. And so we have limited compute power, and that's the That's the same concept that some of the virtual currency is based on, right? So, for example, Bitcoin, and I get into these arguments with people like, oh no, but we have a gold standard. We can only mine so much gold out of the mines. And wait a minute, wait a minute, wait a minute. We don't have a gold standard. We don't have the equivalent gold for the amount of currency that we've printed. No, no, no. We don't have that. So we think we do, but no, we don't have the amount of gold that we're printing this currency on. But virtual currency is different. Virtual currency is based on hashing algorithm. So you need more compute power to be able to create these hashes to be able to have this virtual currency. So what it translates to is actually a better standard than the gold standard, which we kind of don't follow anyway, and which is, let me give you an example. Who is going to have a lot of virtual currency? Somebody who all of a sudden has cracked the code and they are able to compute a lot more hashes at a lot less cost than the current computer systems that we have, right? That's so if a person has a technology that, if they have a technological breakthrough like that, then they can create these hashes and have a lot of virtual currency. uh, that's their competitive advantage. So think of it this way. Let's say all of a sudden an alien technology drops into this world and only one person has that access to that alien technology. Then yes, that one person using that alien technology can create these hashes at a lot lower cost than anybody else in the world, and they're going to be very rich. All of a sudden they're going to have this, a lot of this virtual currency. And that's a finite resource. That's like somebody stumbling upon a a new uh, 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 a new gold mine, and they're starting to mine this new. It's the same thing, except it's based on energy, not on gold, right? It's still a finite resource. Compute power is still a finite resource, and what I see is that a lot of people, especially who are a little technology averse, they can't get their head around that. So it's we're at a point where the virtual is kind of intermingling with the physical. Uh, they cannot get their head around the value of gold versus the value of compute power, because they cannot extrapolate the energy, the input required to come up with a certain output, the output in this case being a hash for a Bitcoin, for example. But the thing is, we are getting, we got off topic, but we are exponentially growing our compute power, which means our AI models are getting that much better. They're getting that much better at processing all these inputs. At the same time, we are coming up with better sensors to have better inputs to these AI. So in an ideal world, it would be sensors in the real world feeding everything into an unlimited amount of compute power, so this compute power can process information from all these sensors. And then all of a sudden, now in a situation like that, this compute you know intelligence can now trade stocks for you, because it has all these sensors, bringing in all this information. It can process it, and now it can figure out, okay, in 5 years so and so stock is going to go through the roof, because it has input from all these different sources, and it has input from all the variables that can impact life on earth. We're talking huge numbers here. I mean, it's not going to happen. I don't think it's going to happen in my lifetime. Let me put it that way. But it's an interesting topic, and I get excited about things like this, and I start rambling, and I start, but I just give you a little insight into what goes on in my head. You don't want to be there.
Yeah, Yeah. Well, it's. I think it's only a matter of time now. The biggest forces trying to stop the change are, and this is just my opinion, I think are mostly the governments around the world and people who want to maintain the status quo. Because once something like virtual currency comes out of play, then you cannot manipulate currency anymore. And it scares a lot of people, and that's why a lot of countries are trying to keep Bitcoin away. And I mean, even in the U.S., I mean, wasn't it not too long ago? Bitcoin, I think some court decided that Bitcoin was not currency; it was a commodity, and because it was a commodity, it could be taxed. And I think ultimately it kind of backfired on what they were trying to do, but it happened. The thing is, it's here to stay. I mean, it's one of those things where it's a better gold standard than the gold standard. Let me put it that way. Exactly. Exactly. So it's something that levels the playing field, whether it's somebody here on the economic scale, or here at the economic scale. So it kind of and well, so there's I mean we've instilled this idea on people who are watching this video, and I'm sure some of them are going to do some research, and then they're going to figure out, they're going to go through this rabbit hole themselves. And uh, and and it's I mean it's interesting technology. We are at the cusp of so many society changing things that are happening like around the same time. It's just an interesting time to be alive. But anyway, I think we need to wrap it up. We've I think we've gone past our time. Yep, yep. Go ahead. I don't right now, but I know in the last video and a few other videos I've had it up. So if you are subscribed to our channel, you'll see several videos that have it on there. But yes, it is. So what we're going to talk about is not just the threats, the threat landscape, but also how to protect your business. So I think that's a lot of people talk about the threats that are out there, and things like that, but not a lot of people talk about how to protect yourself, what to do about it. So we're going to touch on that. We're going to talk about how to, and uh, not to spill the beans, but I'm going to give you one thing that you can implement that will make you sleep better at night. Let me put it that way. I'm not going to give you any more. I'll give you that one thing that you need to do. Just one thing. Implement this one thing. The execution is up to you. Do this one thing, and it will protect your organization, your infrastructure. And we'll leave it at that. We'll wrap it up at that. So, Mac, it's been fun. I just ran back from the store, shipping off my machine. Hopefully, I'll get the new machine pretty soon. I hope they upgrade me or something. Throw me a bone. So everybody have a good day, and be safe out there. I think hopefully we'll snap out of this thing we're going through pretty soon, in Texas. So be safe out there, and that I carry a mask and hand sanitizer with me in the car, because you never know. Um, yeah, every time I get in the car, I'm using that sanitizer, because it's just crazy. And real quick, people are posting all kinds. I'm not going to name any names, but somebody posted that somebody found out that COVID-19 is not a virus, it's a bacteria. And all it does is coagulates blood. And I'm like, come on. I mean, we can look at something like that under a microscope. We have the power to look at stuff like that under a microscope. We can figure it out if it's a virus or a bacteria. I mean, And then I started thinking, no wonder 100 years ago, people used to be so scared of these diseases. They thought, it was like, ghosts or, whatever, because they couldn't see these things. Well, people are thinking these weird things even when we can see them now. And I don't know how the human race survived. I mean, whoa. But anyway, that's so whoever said that to me, I know they'll know who it is, who they are. Um, do your research, check your sources, and if you've checked them already, check them again. So everybody have a good day and be safe out there. And until next Friday, we are out of here. Have a good one, everybody. Bye.